Good day, dear students. Welcome back to Matrices and Systems of Linear Equations. Okay. So what is the learning outcome that we're going to cover in this video is compute the inverse of a non-singular matrix using adjoint matrix. So this is my 8th video on this chapter. Okay. Now, how do we find A inverse? So inverse of a non-singular matrix where the determinant is not 0 can be found using 3 methods. One is adjoint, second is property, and third is elementary row operations. So this video will be focusing on adjoint. Inverse of a 2 times 2 matrix, let's say given matrix A, A, B, C, D, and we want to find inverse, okay people. So please note that this is the symbol for A inverse and it is not 1 over A because this is not algebra, this is matrix. So this notation is A inverse. So A inverse is given by 1 over AD minus BC multiply with, we exchange A and D and we include negative sign in front of B and C. So this will give us inverse of a 2 times 2 matrix. So 1 over AD minus BC here is actually determinant of A, and exchanging D and A and introducing negative sign is actually adjoint A. Now let's look at a 3 times 3 matrix. How are we going to use adjoint for 3 times 3 matrix? So first of all, we need to find cofactor of our matrix and then multiply with the minor. So we know cofactor, we have to find negative 1 to the power of I plus j and multiply with the minor, or we can straight away introduce the sign and find the minor. So once we find the cofactor of matrix A, if we transpose the cofactor, we actually will be getting the adjoint. Okay students? So once we get the adjoint, to find A inverse, we are going to use the same formula for 2 times 2 matrix, which is 1 over determinant A multiply adjoint A. So everything that we are going to use for adjoint is already things that we learned in our previous lesson. We have learned how to find determinant, we have learned how to find cofactor, we have learned how to find transpose. So we are just going to apply all this to find inverse. Okay. So let's try example 13. Find the adjoint matrix of A. So first we find the adjoint matrix. So if you want to find adjoint matrix, so you have to find the cofactor of matrix A and then you have to transpose this. So first we find cofactor of matrix A. So I have done this in one of my video, how to find cofactor of a whole matrix. So first we're going to start with a positive sign, and for the first element we will eliminate row 1 and column 1. So when we eliminate row 1 and column 1, we will be having negative 4, 1, 1 followed by a negative sign, eliminate row 1 column 2. So when we eliminate row 1 column 2, we will be having 2, 1, 1, 1 followed by a positive sign, eliminate row 1 column 3, we will be having 2, negative 4, 1, 1. Okay, so this is for row 1. Next we're going to go to row 2 and we're going to start with a negative sign. For row 2, we're going to eliminate row 2 column 1. Okay, so we will be left with determinant of 1, 2, 1, 1 followed by a positive sign, eliminate row 2 column 2, so we will be having 2, 2, 1, 1 followed by a negative sign, eliminate row 2 column 3, we will be having 2, 1, 1, 1. Okay, sorry, this is the determinant sign. Okay, the next sign will be a positive. To get the minor, we have to eliminate row 3 column 1 and the elements will be 1, 2, negative 4, 1 minus eliminate row 3 column 2. So we will be having 2, 2, 2, 1 plus eliminate row 3 column 3. So we will be having 2, 1, 2, negative 4. So we have done this before, okay, finding the cofactor of a matrix. Okay, so now we're gonna simplify this. Okay, so negative 4 times 1 is negative 4, minus 1 is negative 5. So the first element here is negative 5. 2 minus 1 is 1. 1 times negative is negative 1. 2 minus negative 4. So that would be 2 plus 4, which will give us a value of 6. 1 minus 2 is negative 1. Negative, negative, we will be having positive 1. So here, 2 minus 2, we will be getting 0. And 2 minus 1, okay, we will be getting negative 1. 1 minus negative 8. So 1 minus negative 8 will be 1 plus 8, which is 9. Okay, now here 2 minus 4. 2 minus 4 will give us negative 2. Negative, negative will become positive 2. So here this is negative 8 minus 2. Negative 8 minus 2, we will be getting negative 10. So this is cofactor of matrix A. So remember, we are not finding cofactor, we are finding adjoin. So adjoin is transpose of the cofactor. So when we transpose this, we will get negative 5, 1, 9, negative 1, 0, 2, 6, negative 1, negative 10. So this is adjoin of matrix A. Next, hence find A inverse. So when we have the keyword hence, that means we will be using what we have done before. So we know the formula for A inverse is 1 over determinant of A adjoin A. So we are using the information before, which is adjoin. So but still we haven't found our determinant. Okay, so I hope you remember how to find determinant. You can either use row 1 or column 1 or any row and any column. So I will be using row 1 here. Okay, so which is 2. And I'm not going to find my answer. I'm just going to copy the cofactor, because remember the formula for determinant is actually the first element multiplied with the cofactor. So 2 multiply negative 5. Next is 1 multiply negative 1. So I do not have to consider the sign because we have already considered the sign here. Okay, last is 2 multiply with 6. Okay, so I will be using the cofactor of a row 1. So here we will get negative 1 minus 1 plus 12. Okay, so negative 1 minus 1 is negative 11 plus 12, we get 1. So remember, we are actually finding A inverse. So A inverse is 1 over determinant of A multiply with adjoin A, which is negative 5, 1, 9, negative 1, 0, 2, 6, negative 1, negative 10. Okay, sorry about that. Okay, so now we still haven't finished. So we have to write down our final answer. 1 multiply with this matrix will give us negative 5, 1, 9, negative 1, 0, 2, 6, negative 1, negative 10. Okay, so this is A inverse. Okay, students. So basically this is how we find A inverse using adjoin. By right, this shouldn't be a big issue for you because we have learned cofactor. We have learned transpose. Okay, so we just going to apply this in adjoin, and we have also learned determinant. So we are more like implementing everything that we have learned to find A inverse. Okay, so I hope all of you are able to find A inverse using the adjoin matrix.
Do not forget to submit the solution of this question as a proof of your attendance. Thank you.